Okay, so in this video clip, we're going to take a look again at Tian 1993, that binomial lattice valuation framework proposed by Yixiang Tang. And we're going to implement in C++, following the approach suggested by Espen Hogue and Fabrice Roua. Now, we've made a few small adjustments in the code, but it will use dynamic memory, and we're going to run the C++ code here in this Google Colab. I'll leave the link for the Colab beneath the video and other information relating to the Tian model. So you might, if you haven't looked at the previous video clips, I've set up for estimating Tian in R, Tian 1993 in Matlab, or using the NumPy libraries as configured by Nicola Cantarutti, then you might go back, take a look, but not strictly necessary. I'm going to start here, and we're going to run, fortunately, C++ runs in Google Colab, so that's something that's really practical for estimating this binomial tree. And the approach is something similar to that of Roua and Hogue, based on code that they've made available over the years. Espen's Hogue and VBA. I think I've got the link to Espen's website. Perhaps that would be of some use here. So I'll just take a look. In fact, it'll be easy to find. espenhogue.com, I think. Espen Hogue. And he has a website, and I think it's this one. And then he's a few textbooks, but this textbook is a really useful one. Lots of people use it to when trying to set up a Python equivalent or C++ or JavaScript when they're writing up functions. Typically, people take a look at this. It's a kind of a manual for VBA and automating finance valuations in Excel. And lots of people are familiar with that style that Espen uses here. And I think it's become a sort of set an industry standard in a little bit the way that John C. Hall, also his textbook, celebrated textbook, is kind of an industry standard, right, for understanding and modeling the valuation of different financial instruments. So we're going to run in C++. Now, we have some values that we inputted into the Tian model. We got an estimate of $9.06 for an American call, where the stock price is 100, exercise 100, the maturity is 3 years, the risk-free rate is 3%, the dividend is 7, and the cost of carry here is -4. So this cost of carry is the difference between R and the dividend yield. So dividend must be 7% for this to apply. 20% volatility on the asset price return, and then 500 steps in the trace, because after all, we're using this type of matrix configuration. Okay, so we obtained an R result here of 9.063. We set up in Matlab. We also got, using those same parameters, inputs a value of 9.0638 for using the NumPy approach here as outlined by Nicola Cantarutti. We got 9.0659. That is 15,000, I think. So I might just change that back to 500. And let's run. Okay, so we'll just input in. And for using the approach, now there's some slight differences in the code compared to the original reference. So you might just take a look at the video clip where I went through that. But we're also getting 9.06384 or 85 using Python NumPy code from Nicola Cantarutti, and do take a look at his link here, right? And now for the C++, we're going to run exactly the same parameters. The parameter construction is the same as for the other models. It's Tian 1993. We're going to value call option 500 steps, stock price 100, exercise 100, T 3 years, R is 3%, Q is equal to 7, so cost of carry is negative 4%, volatility 20, it's a call and it's American. If we run that snippet of code, then that gets sent in here to main. We refer to this main, so it goes into our content folder in Google Colab. So that's sitting there, and then if we want to execute that, we've a further couple of lines of code. So basically we take any C snippet, C++ snippet of code, we give it a name, and then we say write file, and it gets outputted here to the content folder. If I double click here, we will be able to see the actual code appear. Okay, we don't need that, just close that off. And then that loads into the content folder, and then to execute the file, we've an additional bit of code we put in. So it's this double percentage script space bash, and then G++, and then the name of the file here, right? And then we estimate, we run that, so the file is now executing, and you can see here we get this 9.06384. Does that compare with the previous estimation? Let's just compare against NumPy estimation we saw before. So it's the same, right? Let's compare against the Matlab code. It's the same if we make the comparison, and against the R function that we had looked at before, 9.0638 is also the same. Those parameters I've taken from Broadie and Detemple. I've left a reference in the introduction here, and and so these values for 15,000 step 3, Cox-Ross Rubinstein 3, we're getting 9.066 according to Broadie and Detemple. So the results appear as if they tally. Okay, so that's C++ run in Google Colab, estimating the Tian 1993 binomial lattice for American options.